Okay, we're going to get started. Going to be pretty much finishing up a look at ARKit, at least for now. The way we're going to do that today is we're going to take a look at Apple's example code and just kind of walk through it together. So I'm going to go to the WWDC website, find the Introducing ARKit, and download the sample app that they have here, Placing Objects in Augmented Reality. Okay. There's a lot of interesting stuff going on with this app. Let's see, which one is it? Oh, Placing Objects. Okay. Drag it out to our desktop. And I want to show you guys a couple of the interesting things that this does. So let's fire up Reflector. Okay. So it is a version of the app where you can place items. So we can place a cup. And so now I'm going to take one finger. So yeah, so it does all the normal augmented reality stuff. It's on a plane, but I'm going to take one finger and I'm going to drag it around, and you can see that it's dragging the cup around on the plane, and it looks pretty smooth. This is not an easy thing to do. The second thing, there's another gesture recognizer where if you use two fingers, you can spin it. So right now I'm using two fingers and I'm spinning the thing around, and I'm kind of like going back and forth at the same time. So those seem like pretty critical things to a lot of AR apps you would want to do. And it's not trivial. And I don't think we're going to get the whole thing figured out today, but I want to start just walking through with you guys some of Apple's sample code, and we'll see how they at least approached structuring their app. I took a very quick look at this last night. Did not get too far, but so we'll just get started today. So we're going to open it up. We're going to open the ARKit example.xcode project. And let's get started. So follow best practices for visual feedback, gesture interactions, and realistic rendering in AR experiences. Provide clear feedback. Help users recognize when your app is ready for real-world interactions. So basically, like if you're waiting for a plane to be detected before you can actually do anything, you want to provide feedback that there is a waiting period and that actually when you find that plane. So if you remember, there was that little square that showed me where I could place the cup, or maybe suggesting where I could place the cup. I think that's what this is, the focus square. Draws a square outline in the view, giving these are hints about the status of world tracking. And then it's going to handle changes to tracking state. Like if your lighting is no good or something happened with your ability to track the world, you want to be handling that in this delegate method. All right, let's get started. We're just going to really walk through what's going on here. So the app delegate is stripped down and simple. This is just the way that I like it. Let's see if there's a storyboard. Just so we can get a sense of the layout of things. Main storyboard. Are they even using it? Okay, they are. So this thing here, just called view controller, is our initial view controller. It looks like everything we saw. It's got the button to add items. It's got this weird looking settings button, which I've probably tried tapping that thing like 20 times to get the two switches to do different things, which doesn't seem to work, which is weird, but that's okay, whatever. We have a scene kit view, which it looks like it is just pinned to the edges. This recycling button over here, that's about it. Now, we also have a virtual object selection view controller. I'm pretty sure that this thing is what we saw when we tapped on here. We tapped on this plus button. I'm pretty sure that's what launched this small table view controller, which is a list of the virtual objects. And, oh yeah, let's see, there's a segue. What is it? Show objects. Okay. And there's another segue, show settings. So this is probably from this thing here. So there's essentially 3 view controllers, a main one with the scene kit view, a virtual objects selection table view controller, and a settings table view controller with some static cells. All right, so let's dive in and start with the first view controller. This is always the best way to analyze the app, just kind of walk through the flow of, especially how it first starts out. Okay, it imports ARKit, Scene Kit, and UI Kit. This inherits from UI View Controller, and we're going to have, let's see, the center of the screen is a CG point. We're going to set up a session, an AR session right away. And we're going to have a closure for the standard configuration. And it's going to be world tracking only, and it's going to detect planes. Okay, cool. So that's how we're going to take care of our configuration. Virtual object manipulation properties. Drag on infinite plane enabled. Okay, that's false. And virtual object manager. Let's see what that is. Type which controls the manipulation of virtual objects. Manipulation of virtual objects, okay? It has a delegate. It has an array of virtual objects. Let's see what our virtual object is. It is a class, Scene Kit, inherits from Scene Kit reference node. Abstract, okay, node that references an external file, okay, and reacts to scale. So it has an array of virtual objects. It can tell you the last one that was used, an update queue, and you initialize this thing with an update queue. So what are the methods on it? So we have an array of available objects. We can flush this and remove all the virtual objects. We can unload virtual objects. Who calls this? Okay. And then we can load them up. So we can load them, unload them, see what's in here, and see what was used last. And it also reacts to gestures. So this is an object manager, so it manipulates them. So it would make sense that it could react to gestures. Gestures is just a class. It doesn't inherit from UI gesture recognizer, which is interesting. I think we're going to have to get back to this though. So it has a private gesture property, current gesture, react to touches began. React to touches moved, so your person's moving their finger around. Ended. So this kind of corresponds to the UI gesture recognizer delegates. React to touches canceled. Yeah, that maps pretty closely. Okay, and then we're going to say update object position. So we're going to translate the virtual objects in a scene view based on a position in the screen, whether or not to do it instantly. All right. So that is translate. This one is set position. set position for object, set new virtual object. So this is probably when we first choose the new object from our table view controller. Load and set position, okay. Update. So this is, I mean, already this is very, very sophisticated. Much more sophisticated than all the demos we've been doing, where we're just essentially placing something down and hoping for the best. Transform. Okay, so it is absolutely a very, very sophisticated way of manipulating objects. And you can see that it's not trivial to just drag an object around the screen. Okay, that's really the core message here. So when you first fire up your view controller, we're going to create this very sort of intensive manager, the virtual object manager. Thank you. Thank you, Nomad. So we got some more properties, a text manager, restart experience button. So restart experience button is that little recycle button that we saw in the storyboard. Okay, so now we have outlets for pretty much all of the UI stuff we saw on the storyboard. We have a queue, so we're going to create our own dispatch queue with a reverse DNS notation. And then, okay, now we're into the view controller lifecycle. So, call super on view to load, and then we're going to call registered defaults on setting. So setting inherits from string. And it is going to have the function we're going to register defaults. So drag on infinite plane values. Okay, so that's going to allow us to register some defaults. And then we're going to go to set up UI controls. So we're going to take our label and our panel. I didn't see the message panel. Let's see, what is a message panel? It's a view, okay. Set up control. So we're going to take our view, we're going to round it, clip it, and hide it. And we're going to set the message label text to an empty string for now. Okay, that's pretty simple. Now we're going to set up our scene. Synchronize updates via the serial queue. Okay, so virtual object manager. Okay, yeah, if you remember, the designated initializer for the virtual object manager required a queue, and we have a variable that created that queue above. So we're going to set our virtual object manager with the serial queue, and we're going to set its delegate to ourself. Scene view dot setup. So then we're going to call the setup method on scene view. Okay. Okay, I lost my place there for a second. So set up UI controls, set up scene. Okay. Scene view dot setup. Scene view dot delegate. So we're going to set the delegate to ourselves, and we're going to set the scene views session to the session that we had created earlier. Scene view scene.enable environment map with intensity. What is that? Scene extensions. Okay. Let's see what that does. So this is in a utilities class called scene extensions. It's an extension on SCN scene. we're going to asynchronously if the lighting environment contents is nil. We're going to set oh, okay. This is actually what we talked about with the physically based rendering stuff before. So if you give SceneKit an environment map, which is essentially a picture of the area you want to be lighting, it can pull information about your lighting environment. So let's see that. That's in SCN assets. Let's see what that thing is. Blur dot. Yeah, so that's just this picture here. Don't fully understand it yet. I don't know how it works, but supposedly it helps with physically based rendering. All right, back to our view controller. So this thing basically sets up your physically based rendering with our serial queue. Then we're going to set up focus square. Let's take a look at that. That is in our view controller. So we're going to use our queue. We're going to call an async method on it. So we're in the background and we're going to hide it, remove it, set it to be a new instance of focus square. So I guess this is making sure that this is making sure that we don't have more than one. And then we're adding it as a child node. And let's take a look at what is focus square. Focus square is a subclass of SceneKit node. It's got a size and a thickness and a scale. And that was that thing that we saw. That was the sort of box-looking thing where we were where we set our cup down. It sort of gave us like a guiding place of where to put our cup. Initialization. So we're going to initialize it. When we initialize it, we're going to set it to opacity of 0. We're going to add a child node to it immediately of type focus square node. Focus square node. Where are you coming from? Focus square node. This thing is really intense. Focus square. Oh, okay, here it is. Lazy bar. It's creating a focus square node consisting of 8 segments. Okay, we don't want to get bogged down here. We just kind of want to understand broadly how this thing is working. Which is challenging. Like, there's no doubt about it. This is totally challenging. Schedule a message, try moving left or right. So this is probably, if there's not enough information to detect the plane, we're going to, if it looks like if in 5 seconds we haven't detected a plane, we are going to show this message of try moving left or right. Okay. Fantastic. All right. So, all right, we're back in our view controller. Let's see how big this view controller is. 246 lines. That's not terrible. So we set up, so is there anything left in setting up our scene? So we set up our focus square, and then we're going to dispatch, once we've got all this done, back on the main thread, screen center, this is UI related code. So we're going to set that property of screen center to be the scene views center, bounds.mid. Okay, fair enough. All right, what's next? So that's it for view did load. Now view did appear. let's talk through this. We're going to, okay, so basically we're going to disable the idle timer, which means that by default in apps, if you don't touch it or you don't do anything for a certain amount of time, I think it's like 20 or 30 seconds, the app goes into the background. This disables that. So you can just let it sit there and just chew on battery forever. Then we check to see if the particular device that we're running on supports AR world tracking. And if it is supported, then we reset the tracking. So we're going to start up the session, and that is session.run. So this is the method you call to start a session. And with that standard configuration variable that we had selected, that we'd seen earlier, with options, reset tracking, and remove existing anchors. So basically, every time the view did appear, we reset everything. We reset tracking, we clear out all the anchors, and we start over. And again, we schedule the message in 7.5 seconds, basically saying, I think it's if you haven't found a plane by now, then you need to find a surface to place an object on. Okay, again, let's go back to view did load. View did appear. So remember, view did appear gets called every single time the view appears. View did load only gets called once. So these things can all happen multiple times. We got to be thinking about that. Otherwise, so if it doesn't support world tracking, we're just going to basically say, sorry, please quit the app. Which seems like the way to do it to me, because without world tracking, it's the AR experience is not very good. And then when the view disappears, we're always going to be pausing our session. All right, so that's all the setup. So we're adding gesture recognizers. Let's see, where are we adding our gesture recognizers? Let's search for where's that delegate getting set here? Text manager, restart experience. Is it in registered defaults? No, I doubt it. No. Show statistics. Okay, I don't exactly see where we're setting ourselves as being the delegate for these gesture recognizers. Oh, okay. There are extensions on the view controller over here. All right, let's just start working through them. Okay, the first one, this is a good way to organize things, but it does, so this is one of the things that is both good and bad about organizing your files as extensions like this. It's good because it keeps everything kind of modularized and it's easier to reason about your code because they're all in separate files with extensions. But the problem is that sometimes you don't know that there's an extension, especially if you're not the person who wrote the code, and it leaves you kind of scratching your head as to how certain things happen. So it's a trade-off. So this is probably the better way to go. It's just not easy sometimes. So let's look at the actions first. I bet you this is what we're looking at. Is there anything about gesture recognizers here? Gesture? Nope. Object selection? How about here? To be honest, I'm a little bit lost. All right, I'm going to try running the app and setting a breakpoint and see if we can get that figured out. Oh, virtual object manager. Are we a delegate for you? Okay, there's the virtual object manager variable. Aha. I bet you that's where it's coming from. Oh, right, because they're... See, that screwed me up, because virtual object manager... No. Transform to change. Did load. Oh, man. All right, I still don't know why. Okay, let's just run the app and see. How is that possible? Oh, okay, I don't think I actually ran it from here before. So I'll set myself as the team. Okay, let me see if I can get you guys dialed in here. For some reason, yeah, I'm just gonna do it. So I'll walk you guys through what I'm doing. Okay, I went to place an object. Oh, wait a minute. Is it like just touches began in general? Okay, it's not even a gesture recognizer. That's what's going on. Okay. This is just touches began on the view in a viewer window. Yeah. Are we setting ourselves up as the delegate for that? Oh, I guess you don't need to. Okay. All right, cool. So that explains that. They're literally just the gesture recognizers for the view, I think, even though it says gesture recognizers. Ugh, that's a little confusing, but okay. Oh, we also have our planes code down here. So, sorry, let's continue with this. We have this. All right, so just to orient everyone, we're back in our view controller. We're going down to the mark here that talks about planes. So this is an interesting way of organizing things. I've never really thought to do it like this. They're not, the authors of this app store things categorically. So it's not like I would normally think to do things where you put all of your variables and whatnot at the top of the screen in one place. They're actually putting the planes related methods and variables in the same place in the app. Okay, that's fine. So we have an array of we have a planes array, which is, excuse me, a dictionary, with the key is the anchor, and the object is the plane, which is a subclass of SCN node. All right, cool. Who's calling this? Add plane. You control renderer. You can, oh, okay. Now we're in one of these extensions. Renderer did add node for anchor. Okay, that's what the standard scene kit SCN AR SCN view delegate method. So this is every time a node / anchor gets added, it calls through to this function, which is add plane. So we generate a plane, and the initializer for a plane is an anchor in this case. And then we add to the dictionary, the planes dictionary, the key is anchor and the object is plane. And then we're adding to the node that we got from the delegate method, the plane. Okay. Cancel scheduled message. This is what I thought. So, you know, there was like the 5-second rule before, where if in 5 seconds show this message, it was like look for the plane. You know, move left and right to detect for a plane. I have a feeling that what this thing does is, okay, well, hey, we got a plane, so cancel that scheduled message. Yeah, that's what that was. Text manager, show message, service detected. Okay, that, I think we saw that before. And if there are no virtual objects, text manager dot schedule message, tap plus to place an object in 7.5 seconds. What? I guess it's like, if you haven't done it in 7.5 seconds, it's time to get a move on. I guess that's what's going on. All right, and these probably, so all right, all this really does is, we're waiting for a plane to be detected. Let's go back to the delegate method. So, all right, so this view controller is a delegate, conforms to the ARSCN view delegate. So basically that main scene kit view that does all the rendering for us. And one of the methods is did add node for anchor. So every time we add a node that corresponds to this anchor, and if that anchor is an AR plane anchor, because there are different types of anchors that are possible. So basically, hey, we just detected an anchor, a plane anchor, so a plane for the first time. Here's what we're supposed to do. We're supposed to add that plane. And when we add that plane, we're back in the main view controller file. We generate a plane. We add it to the dictionary. We add that plane to the node, which just got added to the scene view. We cancel the schedule message saying, hey, you know, look around a little bit. We got to find a plane here. And we show a message. And maybe if we have nothing in our virtual objects array in 7.5 seconds from now, then we show this message. Okay, cool. And now we're going back to the extension. So after we add that plane, we tell our virtual object manager, check if objects should move onto plane. So I really like the way some of these things are named. Like, you can literally sit here and read it and understand what it is. Check if object should move onto plane. Okay, so, and pass in an anchor and a plane anchor node. Let's check out this method. So for object and virtual objects, where's virtual objects? Oh, okay, so we did not inject virtual objects. It's basically saying our virtual object manager has objects. So for everything, for all the objects in our virtual objects, we're going to loop over them. Let object position equal the plane anchor nodes convert position from object parent. Okay. So we're going to convert a plane anchor node's position if the position.y is 0, return. Oh, it's already on the plane, nothing to do. Fair enough. Add tolerance to the corners of the plane. And we're going to create new min and maxes for the x and z values, because a plane has an x coordinate, which is how wide it is, and a z, which is how deep it goes, and it doesn't have any y. It's like a two-dimensional object, so you only worry about the x and the z coordinates. So if the object's position is less than the minimum or greater than the maximum in any of those 4 coordinates, then you want to bail. Move the object onto the plane if it is near it. I like this. Yeah, this is nice. So given a little bit of fuzziness, oh, SCN transaction. I do not know what that is. Transactions are SceneKit's mechanism for batching multiple scene graph operations into atomic updates. Every modification to the scene graph requires a transaction to be part of. Okay. Oh, okay, this is kind of like the animation transactions. So we're going to basically animate. Is this how we do SceneKit animation? Very cool. Or at least it's one way to do SceneKit animation. Again, I am not a SceneKit expert. I'm really just a beginner in SceneKit. It's not something that I work with day to day. So I'm kind of just learning some of this as we go. Now, one thing I find weird about the naming of this method, actually, when I read check if object, I'm expecting to get a bool back. I didn't even look at the return type. I just assumed that it returned a bool, because to me, hey, can you check if the light's on? All I really want to hear back is yes or no, true or false. Check if object should move on to plane is actually pretty poorly named, because we're not passing in an object. We're looping through a whole bunch of objects, and it's not giving us a return type. So that's a little weird, but okay. So it's doing everything we just talked about for every object in the virtual object manager's array of virtual objects. Yeah, okay. So that's every time a node gets added, and really every time a plane anchor gets added. There's other types of anchors as well. I think this is a good stopping point. I mean, a couple takeaways from this is that doing things the right way for an ARKit app like this is really intense. I think a lot of it, if you are a SceneKit expert, probably doesn't seem like all that big of a deal, right? It's I feel like a lot of this ARKit stuff we've been doing the past week and the other tutorials I've seen, it's like 90% SceneKit or SpriteKit if that's what you're using. But I think a lot of people are using SceneKit because it's 3D, and it's like 10% more to understand how to map your SceneKit stuff into the real world space, into ARKit. Which totally makes sense. The people that are mainly going to be doing this work are game developers and people that work with 3D models. So that was a fun dive into some pretty intricate code. I mean, we just scratched the surface for sure. Some things that I would recommend taking a look at are gestures, how they're doing gestures. This is how they're figuring out if you are using one finger, you're trying to move something along the virtual plane. 2 fingers is you're trying to take your object and you're trying to rotate it. And I know that it goes through and it talks about exactly how you map those touch gestures with actually moving things in the ARKit smoothly and then leaving them on the proper anchors. So that's the interesting part to me. I don't know if we're going to come back and talk about this again, because I don't know how effective this is. It was kind of fun for me. I don't know how effective it is for you guys just to hear me talk through a project like this, especially kind of a complex one that I'm not completely proficient in. I don't know how cool that is for you guys, but I would recommend doing this exercise, downloading the app, and playing around with it, set some breakpoints, and see what you can learn from Apple's sample code. Okay, thanks.